Foiling, 80% energy saving, new materials, and electric motors can carry twice the weight of the platform. Swedish design, made in Europe, parts, aerodynamic design. Small boats, even big companies can do small things. Hello.
Hello. So we are from Combitech, although I'm the sidekick, works for Bolina. I'm working for Peter. Peter asked me to bring a presentation that was, what did you say, Peter? Exciting? You said exciting toys, right? And it was not chocolate, it was interesting, right? So I brought Jesper, who is head of the research arena that Saab has for mobile autonomy. I think it's suitable, right, with this context. So, Jesper?
Thank you. It's so nice to be here, and extremely inspiring presentations before, and very much on topic, I think. So I hope with these presentations together we can give some hope of collaborations, maybe initiate some ideas that we can talk about after, how we can collaborate more in Sweden. What can we learn from the defense domain? If we look at the military problem, this is one view of interpretation here. We have, it's constantly coming new threats. We saw Momme here in the beginning, new things coming in. We have drones, needs to be met with quick adoption of new technology. The new technology comes very fast in and needs to be out in the field. That means that all the components can't be the same maturity levels. We need to live with different maturity levels. And with all new technology, all new capabilities coming out, there's a lot of new rules. Every second hour, the drones in a combat battlefield, they are needed to be updated with new libraries to withstand the enemy disturbances. And need to be new rules, new analytics, investigate the data, update models, things that we haven't done that quick before. That means that we can't have learning as we used to do in school classrooms. We need to learn in the field, embedded learning. And communication, you know, your GPS doesn't work all the time. We have communication in the air, underwater, and so we need to learn mixed those domain and learn if we're going to do autonomous systems, they need to withstand a lot of communication. And the picture behind here is an example of a scenario. It's an airbase, and an airbase is a complicated environment like mine. And both a lot of logistics to have fuels and person on the right place, equipment, but it also needs to withstand intruders. So smart idea to monitor the fences around proximity with the drones. Then you end up with how, when we start planes, they need to be careful about the drones. Peter, you mentioned that there are no regulations. We can't even test this. And so we need airspaces that are very small coming down here, new rules, regulations to follow. So it's a complex world. How can we do that? And the message here is that we need to explore together. We need to mix those domains together. So, and the hypothesis here is that it's not a very big difference between different environments here. And I think we saw a lot of examples of that before lunch here also. Coming back to that. So I'm from Combitech, but mainly I say I'm from the WASP program. And I think many of you now know what WASP is, but a very brief 2015, the Wallenberg, Knut Wallenberg Stiftelsen, they funded this WASP research program to raise the knowledge in AI, autonomous systems, and software in Sweden. So this has been ongoing now for many years, and we are in the middle of the program. And the goal here is, one of the goals is to educate over 600 PhDs. And I think around 200 are out there now in the universities, but also a lot of them are in the industries. Some are here, I have met. And good thing here is that it connects all the universities and it connects the industries. And I'm going to talk about the VARA, the research arena for public safety. So you can learn a lot from the web pages, and we can talk after of the other ones. But there are 6 arenas now, and the last one, the latest one was announced by regeringen a couple of weeks ago. So, and there are the big companies behind, just a few names here, but there are a lot of companies around that are in the program. So we said that 1 PhD per week are exiting the program now, going out into industries. So it's a lot of contacts building up there, a lot of new networks and knowledge coming out. So looking a little bit more close to what is an arena and specifically the VARA for public safety. We have the main research topic around it is to work with the collaborative autonomous systems together with humans and society. So it's about agents. We can say agents now. Before it was very confusing to say agents in the industry. Now everybody talks about agents, and it's not interesting if you have a single agents or only a few robots. Put them together, look at how can they collaborate and do much more things together. So in the arena now, there are about 30 projects on a wide field with a lot of PhD students, but we also added a lot of Vinnova projects and startups. So it's a living arena taking care of different maturity levels. And it's also an expert network between big companies. So it's very open to be part of. We have also added the major governments like Försvarets materielverk, Myndigheten för civilt försvar, Luftfartsverket och Sjöfartsverket to work with the scenarios around and the user needs. And I used to always say that it's very similar in other domains like mining, and here is an open door, I think, but for others they don't even know mining. We said that it's a complicated and hard, harsh environment. So all the Swedish universities, almost are the big ones, but the arenas are very open for everybody that work with those topics around there. So what is an arena and what do we do there? We have kind of 6 important areas. First of all is the community, bringing people and organizations together. And we have our way of working is iterative. Every year we have a couple of events. Spring, a field test event, a couple of 100 people coming there. In the autumn, September is a demonstration event. And there are also WASP events around that to gather the community. And during those events in between, we use different methods to collect the needs and push it out to the PhD students and others, and also put them into groups and set up projects together to play with real resources, like some of them you saw in the film. And the resources, they are living in the universities and they are living on different companies, and you come out and use them together. And then we need a system to integrate. Fredrik and the team, you had a very good presentation there. We shared the ideas there. And so very much of that is what we have encountered during my 10 years here, that we need something to put and make it easy to work together. Also one of the big things is to rapidly change the things and make them use for the experiments and support. So The idea a couple of years ago, together with a government institution, we said that this would be this could be also used for defense and for bigger purposes. So the WASP is the arena type 1, very open, everybody can work. And in the end, the third arena that exists like is when you bring the real equipment together, you test it before you ship it out to the Försvarsmakten to make use of it. And in the middle there is needed also arenas that take some of the selected partners and do more secret projects together. So, and what we all want to do is make this flow as quickly as possible. So we go from ideas to products that make value. I'm going to take you a quick fly through the last demonstration event. It was the 8th in a row. We're shrinking down Sweden to the place where we used to be. There is airports, harbors, and everything, and we do demonstrations together. So around over 300 persons made together, and important here is 92 organizations we count. You don't need to read all the names, but it's interesting here that we have a lot of universities together with government institutions, companies, and also a lot of startups. And the startups, I think FlashEye, I think they were there or last year. So there's many of the small companies, they're also interesting for the mining or for other industries. So a quick, how could the demonstration look like when you are 300 persons on the place? You have a lot of equipment. We have air, we have water, we have land, and some buildings. We add the university demonstrations together, mixed domains. We connect them also with industry vehicles and people that are working on ground from other parts in a common search and rescue scenario. Meanwhile, there are also other demonstrations very close going on in the air. And there are also PhD students that are spread out over the area. And they are using some sensors from the startups. And during those days, we have surveillance from the sky. We are photographing, filming everything so we can document and spread. And during a week, there are a lot of different weathers. And safety first. We have safety pilots. As Peter said, it's needing one person per flying vehicle. We need to solve that together. And we bring all that, the crowd, the audience, different places. And that's why we need an airspace, we need communication, and it's a lot of rules, new rules on place to be studied. So here is a lot of experiments going on. It's research, it's on system and on details, and it's jointly creating knowledge together. So that's why we need a system. And here we dive down a little bit. I'm going to show some examples. There's a lot of research areas around, but what we saw that we needed to do is that we need to connect it into a system and place that system into reality. So there are examples of research in how humans and AI for decision support, but there are also how robots work together and a lot of sensors. The system needs to be domain agnostic to cover everything there, and it also needs to be easy integration. If it's a little bit too hard, then someone builds their own, and then we have a silos isolated. So we need to really push for making it easy to work together. And it also needs to be available, so our system needs to be available all the time. I can pick up my phone, go in and work on that and set up instances. And it needs to be based on open architecture, open standards, so you don't get locked in. So don't look at all the boxes, but there are some common things that everybody needs. How can you work with video flows? How can you collect a lot of data? How can you store it? How can you connect APIs? How can you do simulations? How can you run your system on a computer or your own cloud or another cloud? And on top of that, we have created a user interface. So I saw what you did, Fredrik, there. You need to. We have seen that we need both to handle PhD students that want to set up the test. There are engineers who want to have their interfaces, and also end users from fire rescue services, from military. So this our user interface system here is made to be simple to set up different configurations for different purposes, and to cover the basic functions. No one should start to invent and create a road for a BAM map. Can we have those common services based there? So from this, I hand over to Christian, and you will show some example how you have used that.
Thanks. Are you done with the film?
Yeah. Continue.
Nothing more to comment. Then I go.
So-
So, many of you were here last year, right? And you remember then that we had a presentation of a fantastic safety system. Right, Johan?
Yes.
Yeah, and what it's called?
Shield.
And we're using a simulator called?
Robotech.
That's the company. Rosie. Good. Johan remembers. So with that, BSP got excited about our safety system. So they wanted it in their test mines. We had a prototype system, we put it up, and then they call and say, well, you put it up now in Kallio, the test mine, and now we have an important management team. They are going to come there for a demo. And then you realize, have they understood what kind of system we put up in the mine? It's a safety system. It stops machines. That's what it does, right? And this is a test mine in middle of Finland, and they have no machines there. Difficult, right? It's not the best. So what we did was I called a friend, right? I called and asked, can you help me? Yeah, and yes. And of course I didn't have any time and basically no budget. So what do you do? Well, you connect to the WASP platform. And then we were able to do with one vehicle a demonstration. So you see the red car, that's actually a real car. And you see the white one, that's a virtual car. This comes from our digital twin. Here you can see the virtual camera with the virtual car and the real car. So we were driving around, we were demonstrating our system for them in a virtual environment. Mixed reality. Cool, right? It was not the purpose of our system, but our safety system happens to give really, really good position data in real time, and then you can do fun stuff. This is another example. Let's see if we can get it moving. So here we actually demonstrate the breach of a safety gate. Now the gate doesn't exist, it exists in virtual space, but we react. And here you can see we actually meet a big automated machine and the car stops for it. Cool? And the thing is, yes, you can do this. A lot of people speak about it, and this just took a couple of hours. A little bit longer. The platform is easy to use, right? It's open, it's easy, and it has a protocol that is fairly straightforward. I asked Magnus, one of our guys, to do something cool. Let's see what he has done. So you can see this is a demo. It's from down from Rävliden, where we show the system, and you can see then he has used a cesium, a plugin, to the platform to illustrate. And then I said, do something cool. He jumped over to the Finnish mine, Kallio, and shows the setup in Kallio. What is it good for? I'm not sure. It's fairly cool, and you can probably think about cool things you could do. It took him about 2 hours to put it together, make an application out of it. It's fast. And really what we plug in is the real-time data from our platform and our simulator into our PS system. So this is another part. You in the mining industry, you love your local suppliers, right? So do the Finns. So we had a company, Xcube, that they hired. They basically then took WASP, the API plugin, and they built these applications. This is see if we can get it started as well. This is one that is more of a tracking application. This one is more serious. It's a full dispatch system with a simulator for mine activities, with planning for meetings and so on in there. The point is, also here, it's a small company. I think they are like 2 or 3 employees, and they could create the applications smoothly on top of the data that was available. Here you see a visualization on top that actually is the digital twin on top of the true scenario. This we used for a virtual demo. It's really hard to run a virtual demo. You need something to show what is happening and actually the scenario. It works with the platform because you support video and the streams for it. So what we did was you saw Jesper's platform. You have the platform here. We used it. We just plugged in our position system and the simulator.
Thank you, Christian. It's so nice to see that the domains can be mixed here, and why do we want to use it more widely? Yes, because it's if we can maintain the base and build on that, that can be useful for so much and create collaboration on. So we can bring in both students, but also more projects in later on, and create this test environment and mixed. So we are back to where we started. The need for exploration together, very important, and we want to continue to discuss that. And so where are we now? I'm spend a lot of time in Linköping and the region around. We try to create the network between the big companies, the small startups in the yellow here, and also with the end customers, so we can really do the testing. And I think that's what you really need, to be very close to the end users, so you can do experiments in sandbox or in real environment together. So how do you get access to this? We have a portal. You can go to warps.org and you can read about how does it work. You can go to the calendar, see the different events coming up, and on the top, the core system. You will come into where you can read about the system, and you can also go to the API documentation. You can read about it there. You can contact the people behind and apply for an account, and then you got that quickly, and you can log into the Atlas and the different services that are there, and then you can play with it in the open arena, and you can talk to the team and get it installed in your favorite environment, and then continue from there. And it's free to use, and then we need to discuss how can we do it more together. So thank you for that, and look forward to discussions.